Now we're going to look at some volume examples. For the first one, we are just going to find the volume of this right triangular prism. If we notice, the base, again, is a right triangle, and sometimes it helps me to highlight the base so I know exactly what I'm doing. It is a right triangle. I'm given this leg is 3, and I know it's a leg because it's part of the right angle. And the hypotenuse is 5, and I know that's the hypotenuse because it's across from the right angle. But the other thing I'm going to need to know about the base is the other leg, because that is also the height of the right triangle. This is a Pythagorean triple, 3, 4, 5. It's one of the most famous Pythagorean triples, so that one is really worth memorizing. Our volume formula is area of the base times height. And for our triangular prism, because it is a triangle base, the base formula is 1/2 base height. Oh, I'm going to make that a capital H. And then I'm going to do a capital H for the height of the prism. Our base is 3. Our height is 4. And again, those are the base and the height of the base, the triangular base. And then the height of the prism is 4 because that is the distance between the two triangular bases. And then again, I'm just going to take half of 4, which is 2. I like to pre-simplify, although you can always just punch all this in your calculator. 3 times 2 is 6 times 4 is 24. And we're going to just say it's in cubic centimeters. That's kind of what I default to. For number 2, we have a right semicircular cylinder. Right just meaning the base is perpendicular, right? It's not oblique. So remember, an oblique cylinder kind of has this sort of appearance. This is when the height is not the axis here. Basically, like the height and the slant height are different. For our cylinder, our main formula is pi r squared h, but because we only have half, I'm going to go ahead and put a half in there, or I can divide by 2. So this is, remember, is the full cylinder. The other thing I want to notice is, so this is my base, my circular base, and they give me this entire piece here, which is the diameter. And so I'm going to need the radius to complete my formula. And then the 8 is the height, because again, it's the distance between the two semicircular bases. I'm going to give the exact answer here, which means I'm going to leave the pi in the formula. My radius is 3, and then my height is 8. 3 squared is 9. And then I'm going to take half of 8 is 4. And so my volume is 36 pi cubic centimeters. Notice again how I start with the formula. That's for the full. And then I do the formula that I need. And then everything is substituted in, and everything is very lined up, organized, and easy to follow. For example 3, I have a regular pentagonal pyramid. So for a pyramid, my formula is 1/3 base height. And then because my base is a regular polygon, I'm going to use the formula 1/2 ASN. Again, this is just getting me set up for success so that I know all the pieces that I need to fill in. In this case, my apothem is 27.5. And when I substitute that in, that's actually when I'm going to change from an equal sign to an approximately equal sign. My side length is 40. And the number of sides, because it's a pentagon, is 5. And they did give me the height here, which is 30. What again I like about this is all multiplication, so very friendly to simplify with. I can simplify my 1/3 and my 30, and that then is 10, because 30 divided by 3 is 10. And I also want to simplify my 1/2 and my 40. So then that's going to give me 27.5, 20, 5, and then 10. And that's what I'm going to multiply together and go ahead and substitute in my calculator. and I get 27,500 cubic centimeters. Number 4 is really fun. So we have a cylinder with a cone removed. And we can do this a couple of different ways. I'm going to walk you through what I would consider the more straightforward way, and then maybe a little bit of an more interesting approach. So we're basically going to take the cylinder minus the cone. So the cylinder's formula is pi r squared h, and the cone's formula is 1/3 pi r squared h. Once again, they are giving us the width here, which is the diameter, and we are going to have to divide that by 2 to get the radius. The height of both the cone and the cylinder is 16. So they have a congruent base and a congruent height. And I'm going to just go ahead and substitute everything in. 6 squared is 36. Again, before I simplify the 1/3, because 3 doesn't go into 16, I'm going to go ahead and square the 6 first, which is nice because 36 is divisible by 3, and that becomes 12. And therefore, I can have just a much easier time of doing the calculation. So I get 576 pi minus 192 pi. Again, these act like terms, so I can just subtract 576 and 192, and that gives me 384 pi. I have my equal sign here because it is an exact answer having the pi. Now, what we can notice up here, because again, the cylinder and the cone have congruent bases, so congruent radii and then congruent heights. Actually, since a cone, right, is 1/3 volume of the cylinder with a congruent base and the height, this is 3 times that. And so essentially we're taking a whole thing minus 1/3 of that thing. And so that actually leaves us with 2/3 of the cylinder. So if we want to rewrite this, we could just think of this as 2/3 times a full cylinder. Now I've already done the full cylinder over here. This is just a nice way to check my answer. My full cylinder is 576 pi. And so if I go ahead in my calculator, I can either do like 2/3 and then times 576, or I can do 576 divided by 3 and then go ahead and multiply that answer by 2. You will notice that I get the same volume as I got over here, 384 cubic centimeters. This is just a way to check my answer and also another way to approach the problem, and I love when we can approach problems flexibly. And then for number 5, we're going to do a solving problem. So these were more straightforward, although some of them had some interesting parts to them. But number 5 is we're going to have to find the radius, and I give you the volume. So we have a cylinder, the height is 10, and we need to find the radius. So I'm going to start with my formula, pi r squared h. I'm going to substitute the full volume, 1,440 pi, underneath the volume. And then I'm going to go ahead and put 10 in for the height. I'm going to use inverse operations because I'm solving here. And so essentially, I'm going to divide both sides by 10 pi. The pi's will simplify. Sometimes, remember, I just cross out the pi's on both sides, and I don't usually show the dividing by pi at some points. And then the 10s will simplify on this side. And this is nice because 1,440 divided by 10, it's just going to basically divide out that 0 at the end. So I get 144 equals my radius squared. Because I'm taking a value squared, to solve for that, I take the square root of both sides, and I get my radius is 12 centimeters. So great job with these examples. And again, I really encourage you to write everything down, keep everything lined up exactly the way that I've done here.